All right. Hi, how's everybody doing? Hopefully you drank a lot. So my name is Abby Bullock. For the last 7 years, I've been more or less writing science code with scientists in a business context. First working with computer scientists making products for the banking industry, and now working with a team of geophysicists doing the same thing in the oil industry. And I have found it to be really challenging, really rewarding work. So I thought I would share a little bit about what I've learned along the way, in case anybody is interested in doing the same. It's especially a great option for people like me who have math backgrounds instead of computer science. Math! I like it. Thanks, guys. Math is cool. Okay, so first and foremost, if you're considering a career in the sciences, do not limit yourself to only those areas that you've actually studied. I'm neither a computer scientist nor obviously a geophysicist, and I was really nervous about that actually, especially with this last job that I took, because each science has its own crazy vernacular, and you really need to know it seems like, in order to converse with people, to know what's going on. But what I've found is that software engineers really bring a lot to offer to this context, even if we don't know anything about science at all. And the reason for that is that, science for science's sake is not really the point. The point is for everybody to work together to make products that bring value to the business. So you don't have to be a geophysicist. You can and will learn enough as you go along. You got it. Secondly, if you have a job offer for something that's in the sciences, do make sure that there are actually scientists working at the company. I find that it's a really common business anti-pattern for a company to take on a scientific challenge and think that all they need in order to succeed is a bright young programmer. Just isn't really true, I don't think. So if somebody, for instance, is doing an AI thing and they want you to, self-teach yourself to be an AI expert on the job, that might work for you. For me, it's always been a recipe for failure. So approach those things with some suspicion. It's really useful to be able to ask an expert when you're tackling some of these challenges. That was me in my computer science job. That was really dumb. Okay, so you've accepted a job in the sciences, great. I would encourage you strongly to make the first thing that you do be to get to know the scientists themselves and figure out the platforms and languages and tools that they actually like to use. So in my company, the geophysicists tend to like to prototype things in MATLAB and Fortran, and they wire things together using bash scripts. So understanding that, we were able to make some language and coding choices that really aided us in terms of interoperability with the software that they built themselves. It's really important. So MATLAB code can invoke ours. Our code can invoke some of the MATLAB scripts, which is really key for making it easy for them to adopt the software. This is super important because if you don't make it easy for your scientists to use your code, they won't. And you probably won't be at the company for very long. So get to know their tools. And that leads right into the next one, which is, in general, focus on making your scientists' lives easier while you're building these products. Get to know what their pain points are. For instance, when I came in, input-output for this seismic data was really slow and really error-prone. So one of the first things that we focused on was writing a component to handle that stuff for them, standardize the formats, handle the errors, and do it in a reusable way. So this is the value that we really bring as software engineers to these contexts. In general, the scientists are extremely competent coders, but they're not versed in the craft of software engineering. So take your skills and apply them to the problems that are hurting scientists the most. The other side of this coin, however, is it really doesn't matter how beautifully crafted is the code that you're writing if you're building the wrong product. If you're not actually addressing their needs, again, they won't use it. They will work around you and you won't be at the company for very long. So you've taken your job, you've figured out what the pain points are, you've started to write code for them. And my last bit of advice is, I would say focus on writing small and loosely coupled components rather than a large monolithic system. Like I said, we wrote a component that handled I/O. My most successful product at this current company is actually just a series of algorithms that could chain together using a JSON config file. You can deliver value to your scientists and your company more quickly, and you won't code yourself into as many corners. Also, I find that the scientists can wrap their heads around the small components much more easily and feel comfortable with them. So in summary, know your users' platforms, preferences, and pain points. Go after the low-hanging fruit first, for God's sake, go for it. And be fast. Favor the incremental improvements that you can handle with them when you're doing a small, loosely connected thing. And let your users guide which products you're actually building. So at this point, it probably has started to sound a lot like just standard advice for how to do agile product development. And there's a reason for that. I think that good software engineering looks more or less the same no matter what industry you're in. So, no matter where your career in scientific computing takes you next, you'll be sure to be able to take those skills with you. Thank you.